Christopher Davidson. Christopher is a senior water resources engineer with WSP with over 20 years of experience working with municipalities, land developers, power generation, aggregate, and mining sectors. Project experience includes design of stormwater collection and detention systems, hydraulic structures, flood delineation and management, and climate change impacts and mitigation. Christopher has a talent for bringing water resource engineering to life for non-techies.
Thanks. Yeah, so as Jonathan mentioned, I'm a surface water engineer. I've been doing it for a while, and I do enjoy my job. But one thing I've noticed a lot about engineers and the kind of work we do is that we seem to really love being invisible, and it's not a great power. So if you think, I mean, honestly, thinking about the last superhero movie, there hasn't been too many people who had that invisibility power, and there's a reason. It's not a great one. You don't really get to save people from problems. You don't really get to avert big disasters with it. But engineers and biologists, who, especially those who deal with climate change, we seem to enjoy that. So when we're out there in the field, we see a lot of stuff, and when we're in the office, we're doing lots of calculations to kind of figure out what the impacts are going to be. But we tend to keep it to ourselves, and that's actually caused us a lot of problems. And hopefully, that's something you guys can deal with a bit with some of the good tech work you're doing. But yeah, so we know, I mean, we know that there is a problem coming. We can see it in our engineering design. The things we build have to be in the ground for a long time. And we're trying to deal with this, and we see it costing us more and more money, but we're having a large problem kind of communicating with that with people and putting it in a way that they can kind of understand. And one example I had recently that I was trying to deal with was storm sewer cost. So if you imagine you've got your storm sewers underneath the road, they're carrying a certain amount of water, and we've designed that based on the risk. We sort of said we don't want water on the road in certain conditions, so we'll make the pipe this big. But as the climate warms up, we get larger and larger storms, and we have to make those pipes bigger and bigger. And there is a cost associated with that. And obviously, the more we kind of ignore some climate change impacts, the more that cost goes up. So what I wanted to do recently for this project was I wanted to calculate what actually that cost was. So taking three pieces of information, in this case, number one was the stormwater inventory for the city of Mississauga, where I live. So that's basically the GIS, kind of the big database of all the pipes they have. So like from a small kind of foot wide pipe that can fit on your desk to massive like 6-meter diameter pipes you could drive a truck through. And it had the lengths for all of those. So I took that information from the city, and then I took the pipe catalog. So basically that's the catalog of prices I have for my local pipe supplier. And then I looked at the climate change impacts. So I know that, again, for climate change, every time the temperature increases, the air can hold a bit more water. That's kind of the physics of it, that for every degree, it's about 8%. And so if you imagine a storm we designed to carry like 100 millimeters, if the temperature goes up a degree, it's 108 millimeters. So that pipe has to get a tiny bit bigger to accommodate it. So using that pipe catalog and the storm sewer inventory, I can actually work out for each degree of increase for the entire city of Mississauga, how much that costs. And it turns out it costs quite a bit. So look at the graph, I mean, 0-degree increase right now, the cost of everything in Mississauga right this minute is 3.4 billion if we had to rebuild it all today. And that goes up by roughly $200 million for every degree increase. So that kind of gives us a place to start as far as understanding climate change. And that kind of helps deal with that invisibility problem I was talking about. Because we deal with all these impacts, because we're seeing all these changes, it's very hard to communicate those changes. But ways of presenting it like this makes it understandable by people. And that's kind of a big goal for the engineering work I do, is to make, we all see the problems, like engineering, like any kind of like first year engineering student can help you calculate this information. But the challenge, and hopefully something you guys are going to see, but in your good hack challenge, is making that data, making sense of that data and presenting it in a way people can really understand. And that itself is a great power. Engineers typically are not the best necessarily at talking to people, as scientists as well. We do like to have kind of our technical ability, but we really have to have a good speaking ability too, and be able to share the things we find out. So one tool that I've also been kind of working with in my company is something called flood view. So I'll play this little video, just a little part of this video here. So essentially, this was a situation where they had a flooding issue in a nearby town. And this is typically how we'd present that information. We'd have a map and we'd say, okay, under the existing conditions like this, even if we don't deal with climate change, it'll be much worse. And you get these little lines in the map, which are useful, but they're not great. So what these guys did was they took that data again and started playing around with it, and they got what's known as flood view. So basically, what they did was they put that GIS information into their phones and could display that flood level on an essentially GIS overlay. And you can see here they've gone to the higher flood level and back to the lower one. So they've actually been able to display that flood information on the camera view on the phone. And again, for making that stuff visible, this has been great. Like, we usually, when we go with our maps, for instance, we don't get much feedback from anybody. But once we've actually presented that this way, we get tons of feedback. We had one guy who was out there and saw the flood level up against his neighbor's house, and he's like, "Oh, that's my neighbor Frank. He keeps all his expensive tools in his garage, and under this condition, like, he will lose a lot of those expensive tools to this higher flood level." And that's, like, for us, that's like an amazing level of connection with an audience, with the public, that we usually don't get. So finding ways to kind of convey this information is really, really powerful. And that's kind of what I'm hoping to see a bit from some of the good hack stuff. Yeah. And we've done other things we've done is, for instance, we've made little kind of games and stuff to show people how things are changing. This was one I worked with a biologist, just a little simple one where we were trying to talk about how some of the appearance or some of the occurrence of different species was changing in Toronto with climate change. And yeah, it's just simple little ways, even just simple graphic like this, it conveys the picture really well that, blue jays aren't going to disappear from Toronto, but as a species, they're going to become rarer if we don't kind of address climate change. So that kind of, again, that kind of conveying information to people is a really big part. Like, you can definitely solve problems with GIS information, you can solve problems with tools, but the real power for me has always been in the ability to convey it, because that's not something we've done well, but it's something we really have to do, because that power of invisibility that engineers and scientists enjoy so much, it's a power we just can't afford anymore.
And to kick it off,